Hey everybody, this is our series and sequence unit. We're on video 4 and this is our first video about geometric sequences. In this video we're going to go ahead and define and identify geometric sequences. We want to identify the common ratio and we're going to be learning the recursive and explicit definitions. Okay, so to identify our geometric sequences, we're going to be looking for a sequence in which you choose a common ratio is found, and a common ratio different than a common difference. The common ratio is going to be a common multiplier. Okay, now multipliers could be fractions. They could look like division to us. But it takes one term times a value and that continued value. So instead of adding a value to each term to continue the sequence, you will be multiplying by something. That is called our common ratio. Okay, so let's go ahead and look at the first one. And here's how we're going to do it. We're going to have to take a couple samples because unlike an arithmetic, when we were able to really look at the pattern and say, to go from the first to the second, all I did was add 2. And that seems very obvious because adding to us will be a little more, a quicker thing to identify. Whereas a multiplication can be a little different, can be more difficult even, because the numbers will get really big or really small. So for this first one here, I'm going to take the 5, and I'm going to do 5 divided by 25. Okay, so it's always the next divided by the previous one. So this gives me 1/5. So that is our common ratio. Then we're going to do 1 divided by 5, which is also 1/5. Then we're going to do 0.2 divided by 1, which is when you want to go ahead and grab your calculator. And you'll find that 0.2 divided by 1, since 0.2 is 1/5, that these are all 1/5. That is your common ratio. Let's try the next one. 15 divided by -3 is -5. -75 divided by 15 is -5. 375 divided by -75 is -5. So here my R value was 1/5. Here my R value is -5. 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is 3. So we have many ways that we could do this, but it is important that you take it more than just the first two to determine your common ratio. We will find sequences that appear to start geometric but then end up not being geometric, in which we cannot use these formulas. Okay, so take a look at these last two. 4 divided by 1 is 4, but 4 divided by 12 is 3. 48 divided by 12 is 4. So this is not geometric. So I cannot find a common ratio here. I'm done with that problem. I would not be able to write an explicit formula, and I would not be able to use it for anything else. Okay, next one. I'm going to go ahead and do -1/6 divided by 2/3. The reason I'm showing you this example is so you're very careful when you enter this in your calculator. You need to be certain that you're using parentheses on both the numerator -1/6 and the denominator 2/3 when you check to find the common ratio. So I got -0.25. I'm going to do the next one. 1/12 divided by -1/6. Again, make sure you're using parentheses. 1 divided by 12 divided by -1 divided by 6. And that time I got -0.5. So because the common ratio here, or the ratio is different here than it is here, this one is also not geometric. Alright, our recursive and our explicit definitions. Once again, the recursive is used to find the next term. Our recursive definition is a sub 1, and whatever that number is, very similar to the arithmetic recursive definition. And then we have a sub n plus 1 is going to be equal to r times a sub n. Our explicit definition will be used to find any term we want. It's the most commonly used formula, okay? And this is going to be equal to a sub 1 r, which I'm going to put in parentheses, to the n minus 1 power. Okay, so a sub 1 times, not addition, but that's multiplication, r to the n minus 1 power. I'm choosing to put it in parentheses. In the event that my r is a fraction, I want to make sure that I raise it in my calculator, the entire fraction to that exponent. Let's go ahead and use these. Okay, so I've got some sequences here. Oops, I chose one that we can't use actually. Right? Yeah, we can't use that this second one here, so we'll have to change that. I'm sorry. Okay, so for this one though, we found earlier that my r value is -5. Okay, I know my a1 is -3. So my recursive definition will be a sub 1 equals -3, and a sub n plus 1 is equal to -5 times a sub n. That's it. Let's do the recursive definition. We're going to have another cross that. Don't even write that one down. How about that? Okay, so let the right one real quick here. Okay. So for this one, I'm going to again start by writing a sub 1 equals 4, and a sub n plus 1 is equal to the common ratio, which is 3 in this case, times a sub n. This is my recursive definition. All right, we're going to use that same one down here when we get there. So let's write our explicit definition for this one, for our first sequence here. My explicit definition, if you have it right there, is going to be a sub n equal to a sub 1 times r to the power of n minus 1. So I need to only fill in the a sub 1 is -3, the r value is -5, I want that in parentheses, to the n minus 1 power. That's it. Up here, a sub n is going to be equal to the first term times 3 to the n minus 1, and n is our r value. We had that up here. R value is 3. Okay, so we've taken a look at what is a common ratio, which defines that the sequence is going to be geometric. We've gone ahead and identified the r value by using a division and dividing the second by the first, and the third divided by the second, and the fourth divided by the third. Okay, and then you're going to be able to write our explicit and recursive definitions. Nice.